All right, Algebra 2. Here we go, guys. We are starting to look at Section 5, Properties of Exponents. So go ahead and open up your textbooks to page 34. All right, so that's where I am right now. I will admit, I'm telling you guys, we're going to go as quick as we can, but you got a lot of notes to take that you will be doing. Not directly from me, but from this page right here, telling you all the charts that you have to copy, extra example problems I want you to look through, and then a definition right there on top of 7 example problems. So let's do this. Let's get through this. All right. So there are a total of 4 charts. They either need to be memorized or written into your notes. You really need to understand these 4 charts here, okay? This is going to help you greatly in terms of Section 5 and then progressing throughout the rest of Chapter 1, okay? We'll talk a little bit more in Zooms, but you will still be able to use 1 page of notes for Algebra 2 tests. It's a front and back page. That's fine. These charts would be some helpful stuff to have on those notes. All right. So you got 1 chart on page 34, 2 charts on page 35, and 1 chart on page 36. The next thing is I want you to look through examples 1 through 4. All right, that's not like 1-4. That's examples 1 through example 4. Okay, then the next part here is you're going to need to define what scientific notation is. That's on page 36. And I specifically want you to look at example 4 to take a little bit more of a closer peek into what scientific notation looks like. But we will do some examples of it coming up very soon. So here's our example problems. Let's take a look. Number 1, whenever you see this phrase expand, that just means take what's given, make it bigger, okay? So how do we expand? For starters, the 3, there's only one of them. There's the 3. Okay, but this x, there's 4 of them. So 1, 2, 3, and 4 of them. So we're going to have an x, an x, an x, and an x. All right, that's all they're looking for. 3 times, and then x, 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 x. Okay, good, good, good. Let's move on to number 2. Again, you have to expand, but there's a little more involved here with number 2. So let's see, we got some space. Let's make sure we don't crowd number 1 there. So for starters, that negative sign that is in front, and you know what, I'm going to double check this. There's one thing I forgot to write, so I'm going to put that in here. We should have an exponent there. I'm going to make it a 2 just to save ourselves some space. So what that means is you will actually be looking at this negative sign in front. The negative sign is not a part of the parentheses. It's in front of the parentheses. So put it out there. Then how many sets of parentheses do you have? 2, because that exponent right there, you have 2 sets of parentheses. So we're going to go, there's 1, there's another 1. And the 2x minus 1 is inside. Okay. And then you have y to the power of 2. But if we want to expand that, you're going to have 2 y's. So times y times y. Okay. So that's all you are going to need to do. You don't have to do anything more with the parentheses because you have parentheses and then it says this whole thing is brought to the 2nd power. Okay, so that's how you would expand that. Make sure that you don't forget that negative sign out in front because that is part of your answer still. All right, simplifying. So this is where those charts are going to come in really handy because the charts tell you all the info about exponents and what they do. Here's what we got to notice here. Not only is that squared, but it's a negative squared. Now, what does a negative exponent do to the base number? By the way, this whole thing is the base number, the 1/3. It flips it. So we have a negative. That -2 is going to flip the base number. So instead of it being 1/3, it's now going to be 3/1. By the way, 3/1 is the same thing as just 3. So let's just write 3. then that negative sign disappears because we already dealt with it. But the 2 doesn't. We still have that 2. What's 3 to the second power? 9. 3 times 3. So there we go for example 3. All right, let's take a look at example 4. Now, there's a little bit more to this. For starters, we have a variable. The variable has an exponent. We have a coefficient. So now I want you to think of this as the distributive property, okay? So this 3 is going to be distributed into, I really hope the video's still working there. I had a little bit of a glitch, all right? That 3 is now going to be distributed into the 5, and the 3 is also going to be distributed to that 6 right there. So let's rewrite this, okay? We have 5 to the third power, because it's an exponent being distributed, and then we have x to the power of 6, but when you have an exponent, in other words, the 6, to another exponent, the 3, you multiply the exponents. All right? So what does this become? What is 5 to the third power? You could work that out on the calculator. We're working with 125. That's what 5 to the third power is. Then you have x, and then 6 times 3, 18. All right, so we are looking at a couple more examples to go. All right, there we have it. Let's look at example 5. Okay, very similar concept here. You have an exponent on the outside of the parentheses there, and you have all of this extra stuff inside the parentheses. So what that means is this exponent of -3 is going to distribute itself to all 3 parts that are in the parentheses. So you're looking at a -2 to the -3. You're looking at an x to the 3 times -3, and you're looking at a y to the -3. Now you might wonder, is there a simpler way to do this? Yeah, there actually is. So here's the simplest way to do it. If you ever see a whole set of parentheses, and on the outside is a negative exponent, step 1, flip the whole set of parentheses. Here's the direct method. 1 over, then parentheses. Now, mind you, do you notice how we have that negative sign right there in front of the 2? We are going to put that negative sign right there in front, and then we don't need to worry about it anymore. It's been dealt with. There it is. Now, 2x to the third y, and now this is all to the third power. So we still have to distribute that 3 here, here, and here, but everything else has been dealt with. The negative sign's on the outside. You don't have to worry about any more flipping. We just flipped it. So now what you got to do is, what is 2 to the third power? What is 3 right there times 3? Because remember, it's an exponent to another exponent. And then we have y, and that exponent 3 is going to go right to it. So we have x 3 times 3, and y, there's just a third power. So I know we're crunched on space here, so let's see if we can fit it as 1 over, negative sign right there. 2 to the third power is 2 times 2 times 2, that's 8. Then 3 times 3, you're looking at x to the 9, y to the third. So we have our answer right there. Okay. And we have 2 more to go. Now we are focused solely on scientific notation. All right. So for starters, here's a quick info about scientific notation. You must always have one number in front of the decimal. Notice we have a 2. That's one number. It's in front of the decimal. You can have as many numbers after the decimal as you want, but you can only have one and must have one in front of the decimal. Okay. Now the next thing is to remember some of the simplifying exponents that you did in Algebra 1. So notice how we have the same base number. We have a base 10 here. We have a base 10 here. So because the base numbers are the same, you can focus on the exponents right there, 6 and 9. And when you are using division, you subtract the exponents. Okay, so we have some division. The division part, let's do a little break. The division part is right there, numbers in front, 2.325 divided by 9.3. And when you plug that into the calculator, you're going to get just a 0.25. Okay. Don't forget now times, we have that base 10, and 6 minus 9 is going to give you a -3. But we're not done. Remember right at the beginning of this whole thing, talking about scientific notation, you must have one number in front of the decimal, but I don't. I have a 0.25. So I have to change that. I have to move my decimal one space to the right. Okay, I'm not sure on the video if when I pointed that looks like left to you, but we're moving it to the right and creating 2.5 times 10, but that -3 isn't -3 anymore. Why? Because I moved the decimal. So because I moved the decimal to the right, that -3 now becomes a -4. So something to add to your notes, writing it down. In scientific notation, if you move the decimal to the right, you are actually creating a bigger negative. If you move the decimal to the left, you are going to be increasing the exponent. It's going to be a bigger positive exponent. And let's take a look at one of those right now. Last example problem, here we go. So we're now doing multiplication. So these numbers in front, 4, 1.3, we can multiply them. What are we going to get from that? 12.4. All right, spoiler alert, 12, that's 2 numbers in front of the decimal. So we're going to have to deal with that later. Now, same base number, base 10, great. So what do you do when you have the same base number and you have exponents that are being multiplied? You add the exponents together. So -6, we're going to add that to a -4. Okay, so what is -6 plus -4? That's going to give you, don't forget, times 10, a -10. But we're not done yet. One last step. What are we missing here? That decimal has to be moved to the left. So in other words, we're going in the positive direction. So 1.24 times 10. Now a -10, but if you move in the positive direction, you're now looking at a -9. And there we go. Okay, guys. Sorry for the long video. Lots of information going out to you, lots of notes. Good luck with it. Watch it again. Ask me questions during the Zoom if you got them. All right. See you guys in the next one.